So in this video, I'm going to go through page 3 of the study guide for Unit 2. The first few problems, 10, 11, and 12, ask about the fundamental theorem of algebra. And so the fundamental theorem of algebra states that a degree n polynomial has, counted with multiplicity, exactly n zeros. You need to know the wording of it, or the idea of it, but not the exact wording for the test, okay? So for problems 8 through 10, yeah, that's clearly marked wrong. Sorry about that. Use the fundamental theorem of algebra to explain whether or not the functions below could be represented by the graph provided. All right. So first thing you need to know is in problem number 10, f of x is a third degree polynomial. All right. Now, how do I know that? Well, there's x times x times x, which would turn into x to the third power, making this a third degree polynomial. All right. So while I don't know the exact specifics of what third degree or what cubic function it is, I know it's third degree, which means that it would have 3 zeros. All right. Now, 3 zeros mean that this graph, this f of x function, could only cross or touch the x-axis 3 times. So if I look at the graph that's been provided, we've got 1, 2, 3, 4 x-intercepts. So f of x could not represent the graph provided. All right. So the answer is no. The graph, and it doesn't matter which order you write this in. I think it's actually supposed to be this is the graph. Could the graph represent f of x? And so the graph could not represent f of x. All right. Now you should give a reason why. All right. And the quick explanation is what I just went through. So f of x is a third degree polynomial with exactly 3 zeros. But the graph shows 4 x-intercepts. And that doesn't work. All right. So yeah, that's where that fundamental theorem of algebra says that the number of roots, when counted with multiplicity, can only be the degree of the polynomial. All right. All right. So I'm going to move on to number 11 here. All right. So if I look at number 11, we have 1x here times another x here. This would be a second degree polynomial. All right, better known as a quadratic. And so if I look at a second degree polynomial, that means I should have 2 zeros, all right, or 2 x-intercepts. Sometimes we use those terms interchangeably. And if I look at my graph here, I have 1, 2. So yes, the graph could represent the, whoops, let me name the right function here, the g of x function. Okay, so g of x is a second degree polynomial. Let me spell polynomial right here. Polynomial. And the graph shows 2 x-intercepts. So they match, okay? So that's the fundamental theorem of algebra. What we're talking about there is what degree you have has to match the number of zeros you have, all right? So let's take a look at problem number 12 here. So I have x to the second times x times another x. So that would be a total of a fourth degree polynomial, all right, which means I should have 4 zeros. So let's take a look at our graph. We've got 1, 2, 3, 4. We've got a problem here because this graph clearly crosses the x-axis more than 4 times. So the answer is no. All right. No, the graph could not represent h, I'm going to get the right function name here eventually. In this case, it's h of x, all right? H of x, I'm going to get it right. Okay, h of x is a 4th degree polynomial, which means it has exactly, hold on one second, let me get the word exactly spelled right in there. Exactly 4 zeros, but the graph has 5 x-intercepts. All right, so that's the idea behind the fundamental theorem of algebra. So you don't have to know the exact wording of it, but understand the idea that a n-degree polynomial, so whatever n is, has to have n zeros, okay? All right, so I'm going to go ahead and roll on down to problems number 13 through 15 here. These are kind of a throwback to what we did in the first couple of units. You are given a quadratic and you just need to identify the key features. All right, so problem number 13, your a value is positive, so this is going to be concave up. Your x-intercepts are going to be the opposite of whatever is attached to those x terms. So x minus 3 becomes 3, 0. X plus 4 becomes negative 4, 0. So there's your 2 x-intercepts. Rolling right along to number 14 here. Let's see, your leading number here, in this case, it would actually be a negative 1. So this would be concave down. All right, we're in vertex form here. So we're going to do the opposite of what's attached to x and the number on the outside here to actually get our vertex. So that's going to be 3, 9. And then your axis of symmetry is whatever the x value of your vertex is. So x is equal to 3. Number 15, this is in standard form. So your leading number here is positive, which means we are concave up. And your y-intercept is going to be your c value here. So in this case, your y-intercept would be 0, 1. All right. So those are all done for 13, 14, and 15 for those key features. All right. Problem number 16 through 21, we are supposed to solve. So let's start with problem number 16. What I really like about problem number 16 is it's in factored form and it's equal to 0. So take each factor and set it equal to 0. You're going to create, in this case, 3 little miniature equations to solve, and that's going to tell you your 3 answers. So I'm going to solve the one, the 2x plus 5. So I'm going to subtract 5 from both sides. So that's going to be 2x is equal to negative 5, divide by 2. Leave your x value as a fraction. Okay, so that's one answer for our problem. X minus 3 is equal to 0, so let's go ahead and add 3 to both sides. So that's going to give me x is equal to 3. And then last but not least, x minus 7 is equal to 0, so I'm going to add 7 to both sides. So x is equal to 7. Okay, you'll notice I did not multiply this out, and I would not recommend that. In fact, that would be a foolish way to solve this problem. So problem number 17, I'm going to slide on over. X squared is equal to 16. I am going to take the square root of both sides. Square and square root cancel, so x is equal to, now because I put the square root in the problem, there needs to be a plus or minus there, and the square root of 16 is 4, and I'm done. All right, now you could absolutely write out x is equal to 4 and x is equal to negative 4 if you prefer to see the two answers separated. All right, but if you just want to use plus or minus, that is awesome. All right, problem number 18 here. I am going to put this in standard form first, which means I'm going to subtract 3 from both sides. Now I'm going to try to factor this and see what that gets me. Now my factoring is I use guess and check. If you're not a big fan of guess and check, then you can absolutely use the AC method or advanced factoring. All right, quick check here. 2x times x is 2x squared minus 6x plus 1x is negative 5. All right, so those are my two factors. What I just did in my head was to check to make sure that everything turned out right if I multiplied it back out. Because it's in factored form now, I'm going to take each factor, set it equal to 0, just like I did in problem number 16, and I'm going to solve them. So subtract 1, so 2x is equal to negative 1, divide by 2, x is equal to negative 1/2, so that's one solution. Add 3 to both sides here, x is equal to 3. So there's my other solution. All right, I'm going to slide on over to problem number 19 here. So let's see, I'm going to add x to both sides. All right, please make sure that you are not trying to combine terms that are not like, but I do want to make sure that I'm putting it in descending order. I just quickly looked at this and I'm 99% sure it's not going to factor. So if it's not going to factor, that doesn't mean I can't solve it. It means that I'm going to need to use the quadratic formula. So opposite of b plus or minus the square root, b squared minus 4ac all over 2a. And for this particular problem, a is equal to 2, b is equal to 1, and c is equal to negative 4. So let's do a little substitution here. X equals negative 1 plus or minus 1 squared minus 4 times a times c all over 2 times a. All right. So let's simplify this as much as I can. So in my calculator, I'm going to put all of this that's underneath the root without actually including the root. All right. So into my calculator, I'm going to put 1 squared minus 4 times 2 times negative 4. And my handy dandy calculator gives me the answer of 33. So the square root of 33 all over 2 times 2 is 4. Now, if I try to take the square root of 33, I end up with 5.7 and a whole bunch of decimal places after it. There's nothing in this problem that tells me I need my decimal answers, so I'm officially done right here for problem number 19. All right, so I'm going to go ahead and close this video out. I will put up a separate video that finishes the solving problems onto page 4 and then whatever